Hello and welcome to this Tungsten Cluster Masterclass training session where we look at the various command line tools available within the product. In this session we will cover the four main command line tools you will use most often. These are TPM, cctrl, trepctl and thl. There are many more command line tools available and we do cover some of them in the later classes. If you want to see a full list of all of the ones available, please refer to our online documentation. Okay, let's get started. The first tool is called TPM, or Tungsten Package Manager. This tool is the first you'll encounter as it is the way we install and update an installation. TPM also has many other uses as shown here. TPM Validate or Validate Update, depending upon whether you're changing an existing installation or not, will effectively run a dry run of the either installation or the update, and it will report back whether there are any issues on the host. It does a validation of the various prerequisites to make sure they're in place, and it will also check connectivity. If the validate or the validate update is successful, you can then proceed to either the install or the update. TPM Update is used for updating the configuration. Now there are two ways to run this. You can either run just TPM Update on its own, and that will initiate the TPM from the existing installation, or you can run tools/TPM Update from the staging directory, the place where you extract the software package, and that will run the update from that software staging directory. Specifically when you are updating software versions, or you are making quite significant changes to the configuration, we recommend running Tools TPM Update with the Replace Release option, as this will then ensure that any metadata and configuration files are rebuilt cleanly. The No Connectors option to the TPM Update can also be used if you are running the update on a host that has a connector. What will happen there is that the update will make the changes and it will do all the necessary work underneath, but it won't restart the connectors. It will then give you the opportunity to restart the connectors at a time that is convenient for you. But until you do that restart, the connectors will still be running with the old config. So you get the config in place. When you're ready, you restart the connectors, they will pick up the new config and they will run quite happily. Tools TPM Install, it's the first command you will probably use after the validate, and that's to actually do the initial installation of the software. TPM Diag is used to bundle together a diagnostics package, which is super handy when you need our help with any issues you may encounter. It will create a single compressed tar file containing the log files from the software along with status output from all of the components, so the managers, the replicators, etc. Additionally, it will gather operating system and database metrics. This tool will attempt to gather the diagnostics for all nodes within a cluster. So if you've configured passwordless SSH between nodes, great. If not, then you will need to run TPM Diag individually on each node to provide support with a full holistic view of your cluster. It's really important that when you are gathering diagnostics, you do gather a diagnostic for the entire topology, even though you only have an issue on one node. For example, you've got an issue with a replica, the primary node and or the coordinator node log files may also contain additional information required to give support a full picture of any incident that's happened. TPM Connector, TPM MySQL, they're useful shortcuts for connecting to the database. They effectively run the MySQL command line option. The TPM Connector will only work on a node running a connector, and it will route you to the database via the local connector on the host you issue the command from. In most cases, this will route you to the primary node. However, that may be different depending upon your connector configuration. TPM MySQL will only work on nodes running a MySQL database, and it will connect you directly to the database on the host you are issuing the command from. It's important to ensure you do not issue any DML or DDL commands when you connect using TPM unless you are 100% sure you are connected to the primary node. TPM Policy is a quick and easy way of switching between automatic and maintenance policy modes, and I will demonstrate this shortly. TPM Copy and TPM Cert, they're useful if you are running SSL secured installations. I won't go into detail for this tool in this session as they will be looked at in more detail in the SSL specific training sessions. So let's take a quick look at some of these commands in action. Okay, so In the left console window here, I have a connection to my database cluster. So I have DB1 in this first tab, DB2 here, and DB3 here. DB1 is my primary node. Here I have connections to a connector host, connector 1, and connector 2. Now I'm not going to run the tpm validate, the update, and the install commands. The install and the validate was covered in the installation training session, and we cover the update in a later training session as well. I'm just going to go over here first of all onto DB2, and I'm just going to issue tpm diag. Now this will take a few minutes, so I'll leave this running in the background, but it will tell you that it's collecting diag information for DB2. It also says to gather diagnostics for all hosts, use the -a switch, and ensure you have passwordless SSH between the hosts. Now I don't have passwordless SSH connected between these demo hosts, so I would, if I was requiring support, I would have to run this tpm diag on each individual host, DB1, DB2, DB3, and also the connector hosts. That will then provide support with 5 different packages, which we can then extract and view and see the entire cluster state. As you can see, the output says the diagnostic information has been written to this file. So that is the file that I will then download and then send off to continuing support. Okay, tpm connector and tpm MySQL. So over here from my connector hosts, I can issue tpm connector, and this will effectively connect me through to the database, and it's going to connect me through as the application username and password by default that we have configured in the ini file. Now I'm running this on con1, which is just a connector host. There's no MySQL running on this host, but from your visual point of view, it looks like we're running a MySQL connection. Obviously, it brings out the usual header information. It tells you the version of MySQL running, and then we have the MySQL prompt. And if I just do select at hostname from here, we can see we are actually connected to DB1. Now over on DB2, if I issue tpm MySQL over here, this again gives you the same viewpoint. However, this time, if I look at the host name, I'm connected to DB2 because I've run tpm MySQL. So this has connected me through to the MySQL host on the host I'm running on. From here, if I try to run tpm connector, it will actually fail because I don't have a connector running, and it will say I can't connect. Similarly, on my connector, if I run tpm MySQL, it would also fail because there is no MySQL on that host. tpm policy. tpm policy, as I mentioned, allows you to quickly change the policy from automatic to maintenance. I will explain what those policies mean in a few slides time when we look at the cctrl tool. But if I run tpm policy -h, we can see the usage, and we can pass the A switch to put it into automatic mode, the M for maintenance mode. We can also do G to display the current policy, P or S and L all do the same thing. They all various different ways of showing the policy. The --all will display current policy for all services. This isn't applicable in a single standalone cluster, but this would be useful if you are running the more advanced composite clusters, which we cover in later sessions. So I will just do simple tpm policy, and I'll do -G. And I see there it's just returned automatic. Okay, so I will set my cluster into maintenance. tpm policy -M. And we're now in maintenance. If I do the G command now to get that result, it also returns maintenance, and then I can switch back to automatic policy using -A. Very simple and easy way of switching that policy mode. Okay, so as I mentioned, we're not going to cover tpm cert and tpm copy in this session. We will look at that in later training sessions. So tpm connector, just a little extra bit of information from here. As you show that tpm connector takes you through to the database. Now tpm connector can work differently depending upon your connector configuration. So if you're running in bridge mode, which my demo cluster is, then it's just a straight pass through to the primary node. If I'm running in proxy mode, then there are additional options that are available to you. So we have, for example, tungsten connection status, tungsten cluster status. So all of the commands you see here on the screen can be issued from that MySQL command prompt. Now, if I just quickly switch back, I can show you what this looks like. So on my connectors, so this top connector host here, connector 1, if I just come out and go back into TPM connector, this host is running in bridge mode, and this host here is running in proxy mode. Okay, quick visual way of seeing the difference. At the top here you see welcome to MySQL, your MySQL connection is server version, blah, 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 blah. On the proxy mode host, the server version has -tungsten appended. That's because in proxy mode, the connector is intercepting and is being in more control of your connection rather than just a straight pass through in bridge mode. So on my host that's running in bridge mode, if I run tungsten help, nothing happens because it's not valid command. MySQL doesn't recognize it. Whereas on the host that's running in proxy mode, I can issue tungsten help and I can get a whole load of commands. And this is useful for checking, for example, tungsten cluster status. So I can now issue that command and it will give me my cluster status. So this is just an alternative way of using TPM connector. Okay, the next tool, cctrl. This stands for cluster control, and it's the main entry point for managing the cluster, from viewing the status of the node to issuing switches within the cluster. All of these commands can be performed within cctrl. You can issue this on any node running a manager, and you will see the same view consistently across all hosts within the cluster. Just a few of the options are listed here. So checking the cluster state, isolating nodes, switching, recovery. But if you run cctrl help, there are many more different commands you can run. But it must be noted that when connected via cctrl, some of those additional commands can be destructive if not used correctly or without the knowledge and understanding of what you're doing. So be careful if you're trying this out on your own systems. The most common command that you will run will be the ls command, and that shows you that full cluster status. If you watched the simple installation training video, you will see that I ran the cctrl command and followed by ls after I did the installation to view the cluster state. And let's just look at that in a little bit more detail in this session. So there are three key sections when you run ls. The first will be the coordinator line, and this line informs you which node is currently holding that role. In the example you see on the screen, that's DB3. The coordinator role is assigned automatically and is typically given to the first manager to come online. This role is kind of like the manager of all the managers and will be the node that triggers actions based on the rules and the results of the voting mechanisms between all of the managers. If the coordinator host goes offline, the role is automatically reassigned by the cluster. So as a user, you do not need to do anything or worry about this. The next part of this line states the cluster is in automatic mode and is online. Automatic mode means that the cluster will self-heal as much as it can by either trying to bring the components online if they were offline or issuing failovers if the primary node fails. The other policy you'll most commonly use is maintenance. So in the previous slides when I was talking about TPM policy, automatic and maintenance, this is the area that this affects. So with maintenance policy, this disables all the intelligence within the cluster and is used for, as the name suggests, performing maintenance. Typically, if you want to take a replicator offline or do some upgrades, you may not want the cluster restarting things without you being in control. Hence, you would use maintenance mode. It's always recommended, though, never leave your cluster in maintenance mode for long periods of time or when there is no maintenance being carried out. Especially important is to not leave the cluster in maintenance overnight. I'm sure you don't want to go to work in the morning and see things in an unexpected state if there are any issues. The next block lists all of the connectors or routers associated with a cluster. And the final block lists all of the cluster nodes. Let's just take a look at the data source blocks and the information that they show. First, you'll see two different types. There will be one, as shown on the top of this slide here, which relates to the primary node, or the master, and you will have multiple blocks like the second showing the replicas. In the primary node, you have the host and the role and its status, which is self-explanatory, and then you have the progress. So on a primary node, the progress relates to the last sequence number associated with the last transaction that was extracted. And then you have the latency. So in terms of the primary, this is the latency from the last transaction being committed in the database to the replicator writing it into the THL on disk. You then have the status, OK, and then the time that the manager came online. For a replica, exactly the same, except the progress in the case of a replica is the sequence number that the replicator last applied. And then you have the latency, which is the latency of applying to that target database. Within each of those blocks, we then show the state of each component on the node and the roles applicable to them. So every block will show the manager, the replicator, the data server, which is the MySQL database, and the number of connections to that instance. In the case of the primary, the replicator will show the role of master, and in the case of a replica, the replicator line will be slightly different as shown here and will reflect the role of slave and which node it is pulling THL from in the master line. So we see here master equals db1. Another useful cctrl command is the cluster validate command, which performs a simple health check to ensure all components are reachable, and the output looks something similar to what you see here on the screen. Cluster heartbeat is a really good way of ensuring the replication is working. By issuing the commands and observing the progress state in the LS output, you'll get a quick visual that the replicator are replicating. Finally, switching policy is super easy using the set policy command. So you can switch between automatic or maintenance, or as we looked at with the TPM command, if you don't want to log into cctrl to make the switch, you can use the TPM policy command. So let me show you what some of these commands look like in our demo clusters. So first of all, on this left-hand screen, let's say I'm connected to db2 at the moment. So if I issue cctrl from here, and then I can issue ls, and here we have the state of the cluster. So what I didn't mention in the slides is this command prompt here, alpha. That is the service name that we assigned to this cluster when we did the first installation. So here we see coordinator. In my case, my coordinator is the host I'm on, db2. We're automatic, we're online. We have these two connectors, con1, con2. They're running, and then we have our data sources. So db1, as I say, is the primary. Progress is 219, so we've had some transactions going through here. We've progressed on, and all of the replicas, they have the same progress. So that's a good indication that replication is up to date. So if you type help here, you can see lots of commands, and I'm not going to go through all of these. We do cover more of these in subsequent sessions and more of the advanced sessions, so I'm not going to go and run all of these now, but the ones I will run are just the ones that we talked about on the slides. So cluster validate, for example. Here we go, we can see that we're checking for quorum, so we must be at least 2 DB members online. Potential quorum set members, DB1, 2 and 3, majority of 2. We can just see everything here. The conclusion is everything's working fine, basically. On more advanced composite clusters, the cluster validate command, the output there would be greater because it's checking remote clusters, it's checking the cross replication clusters, so there's a lot more for the work to do. If I just go to ls, I'm now going to do cluster heartbeat. So these are my demo clusters. I'm not loading any data into them at the moment, so that progress is sticking at 219. So if I issue cluster heartbeat now, followed by ls, we will see that everything has progressed to 220, and that's exactly what we want to see, and that means that great replication is running. And just to prove that cctrl can be run from anywhere, I can also run it from db1, and we get the same view. And from here, I can do set policy maintenance. Policy is now maintenance, and we can see that's reflected up at the top here. If I come out of here and I issue the tpm policy command to switch back to automatic, I can then go back into cctrl ls and I can see that we're back in automatic. The other good thing to note is within cctrl we do autocomplete, so if you wanted to type set policy, you just start typing the word and then press the tab and it will automatically complete it for you, just to save you lots of typing. And I'm just going to show you that cctrl can't run on a connector host, so if I type cctrl over here, it will just be like, I don't know what that is, it doesn't work. So yeah, you need to be running on a host that's running a manager. Okay, our next useful command is the trepctl command, and this is used to control the replicator and inspect the replication services. And again, it's applicable only to the host on which you issue the command. So whereas with cctrl you can run that on any host and you can see the view of the clusters and control the cluster from within cctrl, when you're using trepctl it's only applicable to the host you issue it on. So let's look at some of the most common options. So trepctl services, this will just give you a short summary of the services running on the host. For a single standalone cluster, there'll be one entry. If you are running more advanced clusters, then you may have multiple entries depending upon how many clusters are in your composite setup and how they're connected. You can then issue the trepctl status command. Now, the passing the service name is optional on a single cluster, but if you are running a composite cluster with multiple services, you would need to supply the service name to capture the particular service you're interested in. And we also have the -r option, which will basically do an automatic refresh every n seconds or until the Control C is pressed. And those options can apply to pretty much most of the status outputs, as you'll see on the subsequent slides. So the status gives you the status of the replicator. Status with name stages gives you a much more complete status view detailing output from each replicator stage. So if you saw the previous sessions where we talked about the replicator, and we have the different stages, so we have the binlog to Q, the Q to THL on the extractor, and then on the applier, the remote to THL, THL to Q, Q to DBMS. So if you run the status name stages, you will get a much more detailed view of progress within each of those stages. So you can see the progression throughout the stage of the replication. The trepctl QS, it's either a quick summary or quick status, however you wish to refer to it, and that will just show you the replicator progress. And again, specify service. If you're multiple services, specify the R if you want the auto refresh. And then the trepctl perf command. This is more detailed status of each of the stages. It gives you in an easy to view tabular format. The output will differ between a primary and a replica because we have those different stages, but I will show you that shortly in a demo so you can see the difference. Trepctl reset, as the name suggests, it does perform a reset of the replicator. Now this is very destructive, so you would not be wanting to run this command ad hoc unless you really needed to or you were instructed to do so. It will effectively reset the sequence number to 0. It will clear out THL if you have the various options to do so, and it will basically put it's like a factory reset almost on the replicator. So if you do that without care, you could lose data and you could corrupt your databases. The online commands, they will take your service online or offline. They can be used with various options as well. But also if your replicator is in an error state and you need to skip a sequence number, then you would use offline, skip the sequence number, then bring it back online. And again, I'm not going to go into detail of the advanced usage of skip, seek, no in this particular session. This is a high-level view of the main tools, and then we look into those more advanced options in later training sessions. So before I show you the trepctl status on my actual demo clusters, let me just talk you through the output that you see in the status, because the status command can give quite a lot of information, and this is going to cover a few slides. So I'm just going to go through that first, and then I'll actually show you that output on those demo clusters that I've got set up. So when you issue trepctl status, you get this output, and let's break it down. So at the top of this block, you'll have the applied section. So applied last event ID, last good latency, etc., and then the applying stage. Now on a primary, this last event ID is the last binary log position that we extracted and wrote to THL. And the latency there is the latency between that database commit to the binary log and the THL output that we wrote down onto disk. And the sequence number is the sequence number that we assigned to that event. The last good latency, last good seek no is handy if the replicator is in an error state. That's a good visual on what was the last thing that we actually applied before we went into the error state, and what was the latency at that point as well. On a replica, that information is related to the last event written to the target database. So although the tags, the applied last event ID, etc., remain the same between a primary and a replica, the actual data has a slightly different meaning depending upon whether you're looking at that primary or that replica. The applying line will show the current progress of a current sequence number, and that's really useful if you're running very long transactions. And sometimes if you're running a long transaction, it may not be visually obvious from the status output that the replicator is doing anything. So the applying line will change and alter as it's going along, so you can actually see, oh yeah, we are actually applying something, we're just doing a long transaction. As the note says here, it will always be empty on an extractor. This output was introduced in version 8, so if you're running an earlier version, you may not see that applying line. The next block is the auto recovery line. So if auto recovery is enabled, the auto recovery total shows you how many times we've automatically recovered. Now within a cluster, those lines are not necessarily relevant. Those lines are more relevant for standalone replication. The current binlog position of the database, so that's where the current database is at, which could be further ahead of last event ID. So if the current event ID is way ahead of the applied last event ID, you can see that there's obviously work to be done for the replica. On a replica node on an applier, that value will be blank. Continuing the status output, the master connect URI and the master listen URI, that shows the source of the THL server we're connected to, and the listen URI shows the server, listener, protocol, host and port that the replicators will connect in on. The pending error sections, this is really useful if the replicator goes into an error state. The information will be shown here. It will be, in some cases, that pending error and the pending error code may be truncated if it's a long error message. So therefore we do recommend you look at the trep svc log file for much more detail if you see that, and that will give you a full breakdown of the error block. The pipeline source, so this is the current source of THL. This example here is from a primary, an extractor, so it's obviously varlib_mysql is where we're getting the binary logs from. On an applier, that information should match the master connect URI, that's where we're getting the THL from. Unless you're using an active-active topology, it may be slightly different because there are multiple routes for the THL on active-active topologies. The relative latency, so that's the difference between now and the timestamp of the last event in local THL. The current role, whether we are a master, as in the primary, a slave, which is the applier, or a relay. A relay node you would only see in composite clusters, and we'll discuss that more in the advanced clustering sections. And the final section, we have the state of the replicator. The many different states that the replicator can be in, online degraded, etc. We did cover some of these in the replication training session, so if you want more detail, go back and review that or look at the online documentation that explains what all of these mean. Now, I talked about latency a lot. So within the cluster and in the replicator, we show two different latency values. We have applied and relative. I don't want to read this full slide word for word, as there's a lot of detail there, but it's really useful in understanding the differences between the two. But in summary, you have the applied latency, which is between the commit of the source event and the time it reached the end of the pipeline. So on a primary, that would be the time the commit happened in MySQL to the time that we reached the last stage in the replicator, which is that Q to THL stage, so we're writing that down into THL log on disk. On a replica, that would be the time from the commit in the database, in the source, to the time it reached the final stage in the replica, which is Q to DBMS, which is the point at which we wrote it into the target database. Now, relative latency is slightly different. That's the latency between now and the timestamp of the last event written into THL. So on a primary, it can indicate whether we are keeping up with the amount of transactions being generated by MySQL. And on a replica, it can indicate how up-to-date the THL that we're reading from the extractor is. Now, it's incredibly important that all nodes in a cluster are in sync with system times, otherwise those latency values can be inaccurate. Additional latency values may not be accurate either if the system is busy with very little traffic. Now feel free to pause the video for a moment or two to allow yourself time to digest the information on that slide if you wish. So what I will do now is I will just show you some of these trepctl commands. So first of all, here we are on our primary node. And if I run trepctl services, we see very simple applied last sequence number, the latency, the role, the service name. So this is the service name if you were to add the service name into the command line. That we're online and everything is good. So this is just a much smaller, shorter version. So if I do trepctl status, that gives that long output of status, and the other option would to be adding the service name would be something like that, service alpha status, give you the same information. So here's all the information we looked at on that slide deck. trepctl QS. That just gives you this very short summary, the sequence number last applied, how many transactions we are behind, what we have stored in THL, and the estimate before synchronization. Now this estimate is very much an estimate. It's not 100% accurate, and it's very difficult to be 100% accurate because until the replicator has got the THL, in terms of a replica anyway, we don't know what those timestamps are. So it's very much a guess, but it's close. It's the best guess we can get, but it isn't. Don't read this as 100% accurate information. If I run the trepctl perf, so this shows us we are on the primary node. So we have, I'm just going to expand this window a little bit so it looks on one line. It might be easier to see. There we go. So we have the binlog to queue stage, sequence number, the latency of that stage, events it's processed, and then some counters of how long this particular stage has spent on the various parts of it, the extraction, the filtering, the applying, etc. And then we have the Q to THL stage as well. If I just switch screens to the applier and I run that same trepctl perf command, you will see that that information is slightly different. And we have the remote to THL, THL to Q, and Q to DBMS. Now I've got a little script that's running some commands here. It's just creates a schema, drops a schema, puts some data in it. So if I just go into TPM connector, because I want to make sure I run this in the right place. And what I'm going to do over here is I'm just going to, on the primary node, I'm going to do trepctl perf with the refresh. And I'm going to say refresh every 2 seconds. Okay, so that's just going to sit there ticking away. So if I just bring this window down and I source this file, you'll see those values increase as it's progressing. Okay, and you can see movement. So if you were watching this on a live system, you would see that movement and you'd be going, great, replication is working. Just Control C to exit that. And if we just switch to DB2 and we run the same trepctl perf -R2, same information there. Obviously that's up to date now, reflective of the primary because it's replicated through. So if I now run that same command, you will see that change there as well. Now what's important here to understand is the various different stages. As I've said, on primary, binlog to queue. So this is as we're extracting from the binary log, putting it into the in-memory queue. then the in-memory queue out to THL on disk. If you see a huge, it's just a little bit of bonus troubleshooting information for you whilst I have the detail on the screen, but if you see a huge difference between the value for Q to THL and binlog to Q, by that I mean Q to THL is way behind the binlog to Q, this is a good indication that we are struggling with I/O and that we're struggling to write to disk. So if you were debugging this, you might look and go, right, okay, we're extracting from the database pretty quick, but we're struggling to write to disk. So let's look at disk contention, those sorts of areas of troubleshooting. On the applier, remote to THL, THL to Q, Q to DBMS. Now THL to Q and Q to DBMS tend to generally be in lockstep with each other. When the queue fills, the next stage will empty the queue and start applying. So these will generally be following each other along quite nicely. However, remote to THL, if you see that one generally falling behind, and when I say falling behind, I mean falling behind in comparison to the Q to THL. Okay, so in this case, you would probably have this perf command running on two places, one on the primary and one on the applier. And if you see Q to THL is way ahead of remote to THL, that's a good indication that you have network contention and that you may need to troubleshoot the network, because it means that we're struggling to bring that THL over quick enough. If you see that this one is progressing quite nicely and keeping up, but then the slowdown and you see that the Q to DBMS is falling behind, then that's an indication that we're struggling to write into the database. So that could be a number of reasons, but you would start to then do some investigative work on MySQL itself, looking at buffer sizes, caches, and seeing if MySQL is struggling with anything. So that's just a little bit of extra bonus there on seeing all of that information. Next, we have THL, and this is the final tool to view in this session. Think of this as our equivalent of the MySQL binlog tool. So it's the tool that you can use to inspect THL log files. A few of the key options are shown here. So help gives you the help. Info will give you that summary information of what THL is on disk. And then we have the list command, which will, if you just run THL list on its own and you have a very busy system, that's going to produce a lot of output, so you would never really want to do that, but you would always give some filtering options as explained here on the screen. So low, where do we start from? High, where do we go up to? First n, last n, etc. And these can all be combined together. We also have the THL index. That's a re-indexing of the THL. The replicators will do this on a restart. It's the way the replicators will find out what we have on disk and what we need to do and what work it needs to do. So if you re-index the THL manually, that can sometimes help speed up a replicator restart. So on a very busy system with hundreds and hundreds of large THL files, the THL index process can be quite time consuming. So do it manually can help the replicator come up quicker. THL purge, use this with care. It will remove THL on disk. And if you remove THL on disk, the replicators can't replicate. We can fix that by regenerating THL, but we can only regenerate THL if the bin logs exist. So you have to balance how much THL you keep on disk with how much binary logs you keep on disk to work that out. Now, obviously, THL is most commonly used to look at THL. So let's just have a look at what the THL output looks like. So this is a simple example of a create table entry. So let's break this down. What do we have? At the top, you have the sequence number that particular THL is referencing. You have the THL file that this particular sequence number is in. You have the timestamp, which is the timestamp that particular transaction was committed to the MySQL binary logs. Okay. And again, if your systems all have different time zones and different timestamps, it can start messing things up. So you do need to make sure that all of your hosts are in sync with the same time and in the same time zone. The event ID, so this is the binary log and the position within the binary log that this transaction exists within. So if you ran MySQL binlog with those properties, you would get the same create table command. the source, where did it come from, and that should be the primary in most cases. Unless you are in an active situation, then that may show a different primary, but it would always be a primary node because that's the source of the writes. We then have a whole block of metadata. The metadata is really useful. This is what we extract from the binary log. It is what we then ensure that we use when we apply the transaction. So all of these SQL modes, for example, these were the SQL modes that were effective when this transaction was committed, along with the character sets. So what we do is we ensure that when we apply it, those same SQL modes and that same character set is applied, so that what we write back is exactly what was written originally by the application. We then have the schema. So that's the database schema that the following SQL is being applied to, or in some cases, if you ran a create table and you fully qualified the table name here. So this could say create table joeblogs.countries. Schema may still show HR because when the command was issued, the client session was within the HR schema. So it doesn't always, the two won't always match. So you need to be careful on that if you're reviewing this and looking at what's what. In this case, my create table statement didn't specify the schema name, so we know that previous schema line is where that table was created. And in this case, it is a DDL command, so it shows the full statement. If your database is running in statement-based bin logging, you would see the statement. If you're running in mixed, you would either see the statement or you would see the row data, depending upon how MySQL has logged that transaction. And if you're running row-based, you would always see row-based information for DML and statements like this for DDL. So what is row-based information? Well, this would be an example of a row insert. We see the action is the insert, the schema is HR, the table is countries, and then we have the row data. Column 1, 2, 3, the size of it, and the actual data that was inserted. Let's just have a look at what some of that looks like on those demo clusters that I've got running. So let me just stop this perf that's running in the background. So the THL is the same on every host. So as long as the THL exists, you can run the THL commands to view that on a replica or a primary. It doesn't really matter which. But if I start here, I'm just going to run THL info. And we can see that this is where my THL is written to. This is the default directory, by the way. You can change this. You can have THL written somewhere else if you wish, and you can configure that within the INI file. Currently, I've only got one log file, and currently those log files are 0.5 meg. The sequences that I have within that one file start at sequence 0 and go up to sequence 648. And then we see the oldest and newest file. Obviously, with only one file, that information is a bit strange, but if you have multiple files, it makes more sense. THL index, again, with only one file, this isn't going to show much, but if you had multiple files here, you would have one entry for each file, and then in brackets here, you would see the range of sequence numbers that exist within each file, which is also a good way of seeing where the boundaries of those THL files sit. So THL list. So as I said, you can do THL list, you can do last, which brings out the very last sequence we have, or you could do first, which will be the very first. You could then add a number onto that. So last or first with 3, for example, will show you the last or the first 3 statements, transactions that we have within THL. You could also say from, and if I said from 100, that would list out all sequence numbers starting at sequence number 100 to the very last sequence number we have. If I said to 100, it would start at sequence, the earliest sequence we have, in my case 0, and give you everything up to 100. You can then combine them. So you could say, well, I want to go from 80 to 100. Then it will just show you a block of sequences from 80 up to 100. So you can see how you can configure those individually. What I'm just going to do here is I'm just going to say THL list last 2. Okay, and there we have the last 2 statements, which were inserts in my case. Now the data here looks scrambled. It's just because of character sets and client encoding. So what I'm going to do is I'm going to give one extra option to my output here and just say give me this in ASCII. So then we can actually read it. So we can see I'm running in row-based logging. Sequence number 648, that was the time we committed it. The binary log that it's in, the bits of metadata that I mentioned. We have the insert, the employees, and then all of this information. If I just go to my connector, and if I just use the database, and I'm going to say delete from employees where, let's see, I think it's ID equals 206. So let's delete that last row. Oh, it's not called ID, it's called employee ID. So let's just correct that. Okay, so I've just deleted that one row. So if I look at the THL last, I'm just going to take that off. Let's put char set back on so we can see. And we can see here that it is now a delete command, HR employees, and it's giving me all of the rows, the full row data. It's formed a composite key, so it's going to make sure that it does a delete where all of these columns match. And that's because I don't have, I've got a primary key, but I don't have indexes set up on there or anything like that. So this is just doing a full delete. Okay. So we do have some other useful tools. We have dsctl, which is an advanced method to reset the replicator positions. So if you did have an issue and you needed to reset replicators, you can use this command and it will set everything correctly. It can even be used then to start the sequence number at a specific place, the binary log at a specific place, etc. I mean, it is quite advanced. I wouldn't recommend using this unless you really do know what you're doing or you're being instructed to do so by our own support. Tungsten, find position, and find seek no, they're useful to interrogate THL. So find position, if you want to look in THL for a specific binary log position, and it will return the correct dsctl command that you can then use for the previous command to do the resets. Find seek no will search based on a sequence number, so you can either look through THL for a specific binary log position or look for a specific sequence number, and it will give you those dsctl commands for your resets. Again, it's advanced stuff. I'm not going to demonstrate it in this particular session or go into detail, and we'll talk about that, as I say, in later sessions. Multi-trepctl. I'm not running an active-active deployment in my demo, so there's no point me showing you this. But if you're running active-active deployments, it will give you a tabular view of all of the replicators across the entire topology and their various sequence number positions. And it's a good way of seeing what is the state of my entire replicator set. So what have we looked at today? Well, we covered some of the basic commands for TPM, cctrl, trepctl, and THL. There are obviously, as I mentioned throughout, there are more advanced commands within each of those that can be used. Some can be quite destructive, and we could spend hours looking at all of the various options, but we just covered the most commonly used ones that will give you the basics to get started in your tungsten clustering training journey. So I do hope you found all of this useful. So it was quite a longer session today with a lot more information. So please go back and rewatch and rewind. And if you do have any questions, feel free to reach out to your continuing representatives. So thank you very much, and I will speak to you again soon on the next training session. Goodbye.